In the name of Allah, the Merciful. First, we thank International Union of the Science and the Research to submit this presentation titled Determination Rydberg Constant Using X-ray Fluorescence Spectroscopy. Team of the work. First, I am Dr. Manahil Mohammed colleague of the Science and the Art Physics Department Qasim University عيون الجوة Saudi Arabian Sudan Faculty of the Science and Industrial Science Physics Department University of Bahrain the first author Dr. Siham Mohammed Hassen College for the Science and the Art Physics Department حفر الباطن سعودية Saudi Arabian and from Sudan College of Education Physics Department Peace University Fula Sudan. Abstract of this paper. The X-ray fluorescence is a non-destructive composition analysis technique which allow measurement in the field and require minimum to no sample preparation. This minimum review represented the physical principle and the example of application of the X-ray fluorescence for the analysis in this study X-ray Fluorescence Spectroscopy. The technique is widely used for the determination of the both measurement and trace element in the three ion oxide Hematite, Magnetite and Kagnatite. This is as Fe and Mn and Cu and As and Pp and Rp at low and the different concentration. Most law was constructed to determine the concept strength and the value of the Rydberg constant for each sample Hematite, Magnetite and Kagnatite was determined to be 2.233 times 10 to power minus 18 joule and 2.144559 times 10 to power minus 18 joule and the last one be 2.329451 times 10 to power minus 18 joule respectively. Keyword: we have Rydberg constant and X-ray Fluorescence spectroscopy. Introduction. X-ray Fluorescence spectroscopy is an element qualification technique with broad application in the science and industrial. It is an analytic method to determine the element composition of a sample as liquid and solid and a thin film. Here we find the application are very broad and including the metal, oil, polymer, plastic and food industrial. When atoms in material sample are excited by the primary X-ray radiation, electrons from the inner shells are erased. The resultant The vacuum are then filled by the electron from the outer shell. Consequently, therefore, the energy it is equal the difference between these two levels as shown in figure 1. Figure 1 shows that if there is any prime radiation hit material, this material composed of the atoms, we find that this radiation make excited for this atom, and we have energy be emitted. This energy it is equal the difference between these two levels. Say that E K alpha, K alpha and K beta it is the spectrum. From this theory we find that mostly who was study K alpha X-ray spectrum at the same time as the Bohr, using the expression but modified Z to Z minus 1 to fit to this experimental data. Thus mostly relationship was E equal E it is energy equal 3R alpha bracket Z minus 1 square divided by 4 times energy E K alpha, equation 1. From this equation 1 we can find that R alpha equal 4 divided by 3 slope, where the slope is equal the rate of the energy in joule divided by bracket atomic number minus 1 square. The above equation is usually referred to as Mosley law. Experimental part. Here we have the sample preparation. We have three experiment or 3 sample of the iron oxide, hematite, magnetite and kagnatite. Prepare through the chemical method. Firstly, hematite Fe2O3 was obtained by using 40 grams of the ferronitride FeNO3 bracket O3 9H2O was dissolved in 500 mole of twice distilled water in polyethylene flask. Then 300 mole of 1 mole potassium hydroxide KOH was added to flask, followed by 50 of 1 mole NaHCO3. This mixture was heated to 90 centigrade till formation of the red brown precipitate of ferrohydrate. The flask and the content were allowed to stand for 48 hours. During this time, the red-brown substitution of the ferrohydrate was transferred to hematite with pH of 8 to 8.5. Secondly, the magnetite Fe3O4 sample can be obtained using full sulfate in air at 500 centigrade through equation below. 3Fe H2 plus 5O3, we find it is equal Fe3O4 plus 3S plus 3SO2. Last one, Kagnatite FeOOH, 1 mole of FeCO3 solution was held in 2 liters in closed vessels at 700 centigrade temperature. This be for 48 hours. During this time, the pH of the system dropped from 1.7 to 1.2, and compact yellow precipitate of Kagnatite was formed. Here we have the equipment. This equipment contains the X-ray tube, and also we have or radioactivity material primer, and we have the primer filter to filter out the unwanted X-ray beam, and also we have the jumper, and here we have detector. The experimental here the X-ray was used to quantify the element composition of the 3 sample. These atoms in the sample material are excited by the cadmium 100 radioactivity source as a source excited for all lifetime of 100 seconds, and the fluorescence coming from the sample were detected by the silicon lithium with the full width and have maximum intensity equal 190 electron volt at 5.96 kilo electron volt. Then the detector receive or the line at the or line for each incident X-ray photon, and the detector generated pulses of the electrical current having highlight proportion to the energy fault. This detector out is amplifier and subject to electron pulses high analysis to separate it. The pulses arise from the surface detector wavelengths. Therefore, by we setting this experiment, and then we have the result. Result and discussion. The statistic data obtained for each 3 sample analysis beginning after the sample compared to blood, and analysis 3 times, and measure and trace element listed in the part per million. Here in the hematite we have this table and figures. Therefore we have the graph between the energy and atomic number minus 1 according to Mosley law. We substitute, then we find that the R it is equal 2.233 times to 10 to the power minus 18 joule. This is agree with the literature review. Secondly, for the magnetite, we have figure 5, spectrum of the magnetite sample. Then we have this table and the graph. From this graph, we use mostly low. Then we obtain the constant R. This R, it is equal to literature review. Thirdly, in Kagnatite sample, we have the most element found in the sample that were recorded in this table, and from this table and the graph, then we plot this graph, figure 8, and then from figure 8 we substitute the slope in the mostly low. Then we find that the constant R, it is equal to 0.32945 to power 10 to minus 18 joule. It is equal to literature review. Therefore, we use that the X-ray spectroscopy is powerful tool for method for stimulated element concentration in the 3 ion oxide sample. Also, it is a reliable method for the determination the value of the R constant with small sample preparation. We have the reference. Thank you very much.